Okay, this is the fourth and the final video segment for the solution to homework number 15, and let me get it for you. We already did problem number 45, so we're going to go and work with number 46. Number 46, which says find the take the expression cosine of 2 sine inverse x. Let's go here. So we have this is number 46. Number 46. So cosine of 2 sine inverse of x. And what you want to do, write this thing in terms of x, algebraically, which means no trig entities should appear here on the right hand side. And the approach to these problems are pretty much the same. They are rather they're problems that require some thinking. So I'll call this thing theta. So we have theta equal to 2 sine inverse of x. 2 sine inverse of x, and that means that sine inverse of x is equal to theta over 2, and that means sine of theta over 2 is equal to x. Okay, now what do we want to find? We want to find this thing. We want to find cosine of theta, but you know from the double angle or half angle formula, this is equal to 1 minus 2 sine square theta over 2. Now notice that what I'm actually doing, I'm referring to this formula on the top left box, the one that says cosine of 2x equal to, except that I don't have 2x, I have theta. So if that 2x is theta, x is theta over 2. In other words, what I'm using for you is actually the identity that looks like this. I'll write it on the side. Cosine of 2x equal to 1 minus 2 sine squared x. Okay? Where I'm saying what I'm replacing this thing with 2 theta. See that? Right there. I'm replacing this thing with theta, and this becomes obviously theta over 2. Right? Yeah. Okay, go. So we have cosine of theta is equal to 1 minus 2 sine squared theta, but look, sine of theta is x, so this is minus 2x squared. Bingo. That's it. That's all we want. In terms of x, algebraically, no trig entities on the right hand side. So basically we have shown that cosine of 2 sine inverse of x is equal to 1 minus 2. Let's solve the problem. Okay, when you look at the other category of problems, let me see, do I have enough pages here? Yeah. Okay, so when you look at these other problems underneath that, these are pretty much the same, except that instead of x, they have specific numbers. So if you look at, for example, number 47, it says sine of 2 cos inverse of 7 over 25. And it's asking you to calculate this thing exactly. Once I get it exactly, then I'm going to go and put it in my calculator to see whether it agrees with what we have or not. So the approach is the same. Let me call this thing theta. So we have 2 cos inverse of 7 over 25 equal to theta, which incidentally means cosine inverse of 725 equal to theta over 2, which means that cosine of theta over 2 is equal to 7 over 25. 7 over 25. Just be careful here. When you write this, you're going back to the stuff that we did, the inverse trig function. It means theta over 2 is between pi and 0. Just keep that in mind, okay? When you write that, it means that theta over 2 is between pi and 0. Go find out when you write cos inverse equal to something, what is the range of values that something can can reside in. Okay, that's this. But anyway, so what do we want? We want, let's see now, what do we want? Sine of theta. We want sine of theta. Look, right there. We want sine of theta. Now we have cosine of theta. We have cosine of theta over 2. So we have a trig identity which says sine of theta is 2 cos squared. Let me see what that trig identity is. Let me go back here. Where is that? Oh, right there. Actually, this is what I want. The one that I want is this top left corner. Let me see. What is it that I want to calculate here? Sine of theta in terms of sine of half angle. Okay, so we want the one that we want is on the top left box, the formula for cosine and the third line. Okay, so it's going to go like this. Right. So that is equal to actually we need the half angle formula for sine. It's the sine formula that I want. So we have 2 sine theta over 2 cosine of theta over 2. When I took to that table, I said, look at the cosine formula. I actually want the sine formula. Now, this one we already have. We know that this is 7 over 25 right there. You see that from here. So what we need is to find the cosine of that. But cosine is, let me draw it like this, plus or minus square root of 1 minus cosine squared theta over 2, and then sine of the cosine, and then cosine of theta over 2. That we have, no problem. The question is, which one of these two algebraic signs do we want? Do we want a positive or a negative? Well, notice that if theta is between 0 and pi, sine of theta is positive. So we want the one with a positive because theta over 2 is between pi and 0. That means sine of theta over 2 is positive, which means pick the plus sign. Pick plus. So we have sine of theta equal to 2 square root of 1 minus cos squared theta over 2 times cosine of theta over 2. So 2 square root of 1 minus, what was that cosine? It was 7 over 25. 7 over 25 squared, and then 7 over 25 outside the radical. As far as I'm concerned, this is a perfectly legitimate answer. However, the answer in the book, they may have simplified it. And what I do suggest is that, let me actually simplify this thing. This is going to be 2 square root of 625 minus 49 over 625 times 7 over 25. And this is, let's see now, 625 minus 49. This must be a nice round number. That is 6. I don't know what this thing is. 2 square root of 576 divided by 25 times 7 over 25. What I suggest is you put this thing in your calculator and you put this thing in your calculator, and you better get the same answers. Okay, I'm not going to do that. I'll let you worry about it. You can do that yourself. Next problem along the same line. This is number 48, and it says get the exact value of cosine of 2 tan inverse of 12 over 5. 12 over 5. 12 over 5. Exact. Don't use a calculator. Once you get an answer, you can go and put that thing in your calculator. You better get the same answer. So let me call this thing theta, just like we did before. So we have 2 tan inverse of 12 over 5 equal to theta. That means tan inverse of 12 over 5 equal to theta over 2. And notice that as soon as you write that, as soon as you write this, it means theta over 2 is less than pi over 2 and minus pi over 2. As soon as you write tan inverse equal to something, that something must be between pi over 2 and minus pi over 2. Remember, this was done when we discussed inverse string function. Now, this also means tan of theta over 2 equal to 12 over 15 over 5. Now, what do we want? We want cosine of theta, right there. You want cosine of theta, knowing that this is what tangent of theta is. Okay, so we've got to find the appropriate formula which relates cosine of theta to maybe, I don't know, tangent of half of that. So let's go and see whether we can find something okay, right there. Look, just uh, just look at well, I'm trying to find something which relates theta and theta over 2. Right. Okay. If you look at for example, the left boxes, the middle one, the one which says tan squared x equal to 1 minus cos 2x, etc. So tan squared x, just remember the one that I want is this. Okay, let me erase that. That formula says tan squared x is equal to, and what was it? It was 1 minus cosine of 2x, 1 minus cosine of 2x, 2x divided by 1 plus cosine of 2x. Okay, so we want this. And how are we going to use that? So if I replace for x theta over 2, so we say tangent of theta over 2, tangent square of theta over 2 equal to 1 minus cosine of 2 times theta over 2 divided by 1 plus cosine of 2 times theta over 2. Clean it up. Tangent squared theta over 2 equal to 1 minus cosine of theta over 1 plus cosine of theta. Okay. Now, what do we know about tangent squared? Well, tangent squared. Well, we know that tangent of theta over 2 is 12 over 5. So this is going to be 12 over 5 squared equal to 1 minus cos theta divided by 1 plus cos theta. Okay. So let's clean it up. So 144 over 25 equal to 1 minus cos theta over 1 plus cos theta. Let's cross multiply 144 plus 144 cos theta equal to 25 minus 25 cos theta. Take all the stuff involving cosine to the left side. So I take this thing to the left side. So we go 169 cos theta equal to, and take this thing to the right hand side, 144 minus 25. So we go 169 cos theta. Well, actually, this is a minus, this is a plus, right? A minus, what is that? 5 from 14 is 9. It looks like this is what we've got. So we have cosine of theta, this is what we wanted, equal to minus 119 over 169. Now I'm going to check because this looks suspicious. So if I put this thing in my calculator, and if I put this in my calculator, I better get exactly same answer. So let's go ahead and do that. This looks suspicious. Could be that I made an algebra error somewhere, but we're going to find out. If that is the case, then I'm going to go back and find out what I did wrong. second. Clear all of this. Okay, first thing I'm going to do is whatever they gave us, which was actually, what was it? Cosine of 2 tan inverse of 12 over 5. Okay, what's my mode here? First of all, make sure it's radians. Radians, so scroll down, it is radian, very good. So let's go back. Okay, all right, backspace. Okay, so we have cosine of 2 times tan inverse, second function, tan inverse of, what was the thing, tan inverse of 12 over 5, 12 divided by 5. So this is what was given to me, and that's the number. Now what I got was minus 119 over 169, minus 119 over 169. So minus 119 divided by 169. I better get minus 0.7 or something. Great. Okay, so we did right. All right, the last problem is this word problem. It's very straightforward, actually. Let's see what we got here. Let's see. Okay, we did everything. We're down to this word problem. It says that, look, there's a log here. This is a cross section of a log coming out of the board, coming out of the screen. Okay, and we want to cut a beam like that, a rectangular beam. Okay, so suppose that the diagonal of the beam is 20 inches right there. This is diagonal, and this angle is theta. It says show that, first of all, the area is 200 sine of theta. If we know what this angle is, it says show that the area is 200 sine of 2 theta. So it's a very simple problem, actually. So let's go here. I'll do it right there. So this is the last problem, the word problem, number 105. So basically the beam looks like this. This diagonal, you're told that it is 220, and this angle is theta, and this is a rectangle. Okay, so in this right triangle, this height is 200 sine of theta, and this side is 200, not 200, 20, I meant 20, not 200, 20 cosine of theta. Please make sure that in this right triangle, you can write the sine of theta and cosine of theta and find these things. So the area of this rectangle, area, which is a function of theta, for a rectangle is the product of these two, 200, 20 sine theta times 20 cosine of theta. This is 200. This is 200 or 400 sine theta cos theta. But we know that 2 sine theta cos theta, if I wrote it like this is sine of 2 theta. The moral of the story is area is equal to 200 sine 2 theta, just like what I was asked to do. And then it says, convince yourself that the biggest area that you're going to have is 200. That should be obvious because the biggest value that sine of 2 theta can have is 1. Remember, sine in magnitude is always less than 1. So a max is 200 square inches. And this happens, obviously, when sine of 2 theta is 1, which means theta is equal to pi over 4, 45-degree angle. And that takes care of this homework.